one more example of independent and dependent events, tree diagrams, labeling of trees, and so forth. Let's say that we have a single die. We're going to just roll a single six-sided die. And a number is going to come up, 1, 2, 3, 4, 5, or 6. 2f means that the number we get can be factored into two other numbers. That is, 4 is 2 times 2, and 6 is 2 times 3. None of the other numbers that can come up, 1, 2, 3, or 5, has two factors. 2, 3, and 5 are prime, and 1 has only itself as a factor. So that the probability on a single roll of getting two factors is 2 out of the 6 possible outcomes, or 1/3. Now let's say that we roll the die, and then we roll another one. We have two dice with this property, or that they have the usual properties, but this is how we're going to judge them. So if we roll two dice, well, we can either get two-factor number, which is 1/3, that means either getting a 4 or a 6, or a one-factor number, 2/3, probability of getting a 1, 2, 3, or 5. Okay? Then the next die, well, there's a 1/3 probability that it'll give us two factors, and a probability that it'll, 2/3 probability that it'll give us 1. And similarly down here. So our tree diagram shows us what the probabilities are. And we can zoom in and see that we've got the 1/3 here, the 2/3, the 1/3, and the 2/3, just like we have the 1/3 and the 2/3 here. Okay, so that the outcomes would include two factors in the first, two factors in the second die. What's the probability of two factors and two factors? Well, the dice we assume to be independent. What comes up in one die has nothing to do with what comes up in the other. So that since these probabilities are independent, probability of two factors and two factors is 1/3 times 1/3, or 1/9. Okay? We could have two factors and one factor. Okay, well, the probability of one factor and two factors is 1/3 times 2/3 is 2/9. I might have been better off writing that as two factors and one factor, although clearly it doesn't make any difference in what order we write them. It would have been a little more consistent here with the way I've written them over here. So really, I kind of reversed these from the way I really should have written them down. It's not incorrect. It's just not real good form. So then the next outcome is one factor, two factors. That corresponds, of course, to this path through the tree. And the probability is 1/3 times 2/3, or 2/9. And then one factor, 2/3 and 2/3. 2/3 times 2/3 gives us 4/9. Okay? And of course, these numbers add up to 1 and 2 is 3, and 2 is 5, and 4 is 9/9, or 1.